All right, calculating density. Calculating density. So first of all, we need to know what the formula for density is. Yes, density is equal to M over V. M being the mass, V being the volume. I learned about this in high school, and some of you have probably seen this before. Again, if you've learned it in your science class, you take a triangle here, you got D, M, V, okay, like where you go to get your license. Your line right here means divide. Okay, your line means divide. So if you're looking for density and you have mass and volume, density is mass divided by volume. If you're looking for volume, volume is mass divided by density. Okay? If you're looking for mass, if they're beside each other, what do you think we do? Multiply. Density times volume gives you the mass. All right, so that's just a little trick there to help you out in case you struggle with remembering that or how to manipulate the equation. Okay, so DMV, you divide or you multiply if they're right beside each other. All right, so let's look at an example here. A cylindrical piece of wood has a diameter of 2 feet and a height of 5 feet, and it has a mass of 600 pounds. What is the density of the wood to the nearest pound per cubic foot? So first of all, to make sure our units all agree with what they're asking us for. It wants density in pounds. Is our mass in pounds? Yes, we're good. It wants the measurement is in cubic feet. Are our measurements in feet? Yes, so we're good there. Sometimes sometimes they will give you units that do not agree right off the bat, and you have to do something to them to start with. It may have asked for density in cubic yards, so you would have had to convert those feet to yards first. Okay, we don't have to do that in this case, but so if we want to find density, we need mass. They gave it to us. They gave us the mass. We need the volume. Did they give us the volume? No, but they gave us the information that we need to figure it out, right? Volume of a cylinder. What is it? Pi r squared h. If you don't know, y'all got to know these. Okay, you've got to know these. Volume is pi r squared h. So our radius, did they give us the radius? No, they give us the diameter. What's the relationship between, if we have diameter, how do we find the radius? Divide by 2, very good. So we plug 1 into our equation. The diameter is 2, then the radius is 1. The height is 5. So we have 5 pi for our volume. Leave it in terms of pi right now. Leave the rounding for the very end. So density equals mass divided by volume. Be careful with this. Okay, you have more than one term in the denominator. You have 5 and you have pi. So when you type this in, you've got to put parentheses around the 5 pi. Or what your calculator is going to do is it's going to take 600 divided by 5 and multiply that answer by pi. If you don't put any parentheses, that's what it'll do. So the density here, it says to the nearest pound per cubic foot. So that would be 38 pounds per cubic feet. The unit should make sense, right? Our mass is in pounds. Our volume, remember volume is always whatever your measurement was cubed, because you multiplied 3 dimensions by each other. Questions? That one's pretty straightforward. Okay, that one's straightforward. Let's look at another example. A certain type of metal has a density of 5 grams per cubic centimeter. A piece of this metal has a mass of 2 kilograms. What is the volume of this piece of metal to the nearest cubic centimeter. All right, so first of all, let's check units. Do our units match? The density is in grams per cubic centimeter. Do the units of our mass match that? It's in kilograms. We got to convert kilograms to grams. Does anybody know how many grams are in 1 kilogram? 1,000. Okay. 1,000 grams per 1 kilogram. So if we have 2 kilograms, we have 2,000 grams. All right, we want to know volume. We can find volume by dividing mass by our density. Volume is mass divided by density. So our mass is 2,000. Our density is 5. So when we divide that, we get what? 400. And that would be cubic centimeters. Our density told us what those units are. The density was in grams per cubic centimeter. The grams is the mass. The volume is the cubic centimeters. All right, so very important. Always, always, always check your units. Make sure those agree. And then sometimes you'll have to calculate the volume. Now, they don't always ask you about densities involving mass and volume. Okay, sometimes the density does not have to do with mass and volume. Sometimes they'll talk about population density. Okay, so a general equation for density is your amount divided by your space. How much do you have divided by how much space it is occupying. So that still works for mass and volume. Mass is how much you have, volume is how much space you're occupying. But if we're talking about populations, your amount is how many people you have, your space is what area you're talking about. So in this problem, it says Beijing has 20.7 million people and an area of 16,400 square kilometers. Shanghai has 23.7 million people and an area of 6,300 square kilometers. How many times as great is the population density of Shanghai as Beijing? So let's find these population densities. Let's do Beijing population amount divided by area. Shanghai population amount divided by space area 6,300. Let's use our calculator, see if this will give us decent numbers, maybe usable, probably not. Okay, so we've got that decimal 0.00126. 23.7 over 63. Whoops, too many zeros. Okay, so what is this saying? Okay, there are that many million people per square kilometer. Okay, that many millions people per 1 square kilometer. Now, I know that decimal doesn't look that very big, but if we think about millions, right? Move that decimal how many places? 6 places. And that'll tell you how many people are per square kilometer. We got to figure out how many times greater. What does it look like? How many more times greater? 3. Okay, if we multiply 0.0012653, pretty close to that number. Okay, so about 3 times more dense. So that means there are 3 times as many people packed in a square kilometer in Shanghai than there are in Beijing. And we're talking millions of people. There's a lot of people. Yes, sir. Yeah, that's just talking about how many times greater is the population, but it says the population density. Yeah. Yes, absolutely. If you're just trying to figure out how many more times greater the population is, you would just do the 23.7 divided by 20.7. So that doesn't look like it's that many times greater. But when you factor in how much area you're talking about, Shanghai is significantly smaller than Beijing is, and they have more people. So it really shows the disparity there, the difference between the two. 3 times as many people. All right, so that's pretty much all I want to show you about density. Let me mention one more thing, and I think y'all know this, but I just want to make sure. Okay. Density has to do with floating. Okay, density has to do with floating. If something floats versus something sinking, which one is more dense? The thing that floats or the thing that sinks? The thing that sinks. Okay, if you're more dense, you're going to sink. If you're less dense, you're going to float. Okay, just wanted to make sure everybody was good with that. All right, really quickly, let's talk about surface area. Okay, let's talk about surface area. These are what I want you to add to your formulas from yesterday. So where you have those volume formulas on your notes from yesterday, go ahead and add the surface area formulas here for a sphere, a cylinder, and a cone. And I'm going to write these a little bit bigger just in case you can't see them. So for a sphere, it's 4 pi r squared. That's your surface area, is 4 pi r squared for a sphere. For me, the easy way to remember that is pi r squared is the area of a circle, right? Ignore this one, has an extra 2 in it. Pi r squared is the area of a circle. And there's a calculus way to prove why it ends up the way that it is, why it's 4 times the area of a circle. But as far as remembering this one versus the volume formula, I know volume has to be cubed, so volume is r cubed, and then the 3 goes with the 4/3. Cubed, 4/3. Okay, the squared just has the 4. That's how I keep them straight. Surface area of a cylinder. Anytime you're finding the surface area, you're adding up the area of your surfaces. So let's think about the surfaces of a cylinder. We got a circle on top, we got a circle on the bottom. That's where the 2 pi r squared comes from. That's the 2 bases, which are circles. Pi r squared is the area of a circle. You got 2 of them. Okay. This is the area of the outside of that cylinder. If we unrolled that cylinder, what shape would that be? A rectangle. Okay, it would be a rectangle. So the height of that rectangle is the height of the cylinder. That part's not hard. Okay, the height of the rectangle is the height of the cylinder. But if you think about unrolling that rectangle, that length of that side, anybody know what the length of that side corresponds to? The circumference of the circle. If you go all the way around this circle and you unroll that, that's going to be the length of that rectangle. That's where the 2 pi r comes from. 2 pi r is circumference. So that's the width of your rectangle times your height. The width is the circumference. The height is the height of the cylinder. Okay, that's where that formula comes from. Now the cone is a little bit more involved. The base is the easy part, right? This says pi r s plus pi r squared, if you can't see it, is the surface area of the cone. The pi r squared is the base. The base is a circle. That's the area of the base. Finding the area of the outside of the cone is a little bit more involved. because it's not exactly a rectangle, if you roll it out, it's kind of a triangle, but the triangle has a curve on the bottom of it. So it's pi times r times s. Notice the s labeled on this picture. That's the slant height. Okay, that's the slant height. It's the height of your cone from tip to the edge of the cone. Okay, from the tip of the cone to the outside edge of the cone is the slant height. H is the height from the tip perpendicular to the base. Okay, those are two different values. Sometimes they will give that to you. Sometimes you may have to use the Pythagorean theorem to figure it out, because that is a right triangle. I don't know if you can see it well in this picture. This is a right triangle right here, okay, with the radius and the height being the legs, and the slant height is the hypotenuse. So you may need the Pythagorean theorem to figure that out. Okay, the radius and the height are the legs, the slant height is the hypotenuse. All right.